So hello, welcome back to the second part of building my Voron Trident. In this video we'll actually finish the build, and the last part will be about installation, first prints, and also assembling the upgrades that come with the kit, for example the door or the fume packs. There are a few parts who need pre-assembly before installation. For example, for the printer feet you can see right now in the background, we need to insert some M5 nuts and secure them with super glue. Next step is a pretty simple step. We just have to fixate the power inlet to a part of the 3D printed skirts. Another part of the skirt is the display holder. Therefore we have to first place the display in its corresponding case. And afterwards you just have to attach the display to the part of the skirt. In my case there was a little problem, since the screws that are recommended in the manual are just a few millimeters too short, and that is why I was just able to pull it apart. Alternatively, you can just use some leftover screws that are a little bit longer, and don't worry, there are enough included in the kit. Now we are already installing the printer feet, and watch out because each of these feet is meant to be in a specific corner. If you accidentally swap out two of the feet, the bottom plate might not fit perfectly and you have to adjust it later. Now for the skirts, since I ordered the cheaper version with no decorative parts, we only have two parts of the skirts, and that's the power inlet and the display holder. But we can just print the remaining parts of the skirts ourselves once the printer is finished. Next, I'm installing some of the printed parts onto the Z linear rail. Unfortunately, I forgot to record how I assemble these, or just can't find the files. So I will only show you the manual entry, that way you can at least see what I've done off camera. Next we'll attach the C motors with the threaded rod, and for that we'll spin them a little bit until they are stuck to the printed parts we installed earlier. And afterwards we'll secure them with some M3 screws, but watch out for the direction the cables are pointing. Finally, it is time for some actual electronic stuff. First we need the bottom plate, and we'll just attach the power supply with some screws. For the next part we need these hexagonal nylon spacers, and these are used to create some distance between the bottom plate and the main board. Before attaching the main board to the bottom plate, I can recommend to skip forward to the wiring step and already plug in the Raspberry Pi board, because when I did that I didn't press it in far enough, so the contacts weren't perfectly matching, and that way I had some problems when initially starting the printer. Next up is a solid state relay, or SSR for short. This one will be used to control the heat bed, because it's such a high voltage component. The last part is the cable connector, and afterwards we can already install the cable ducts, which we have to trim down first such that the holes match with those on the bottom plate. I did that by laying out the cable ducts and marked the leftover that I have to cut off with a hobby knife, and later on use the saw to cut them to the right length. At this point the manual suggests you do some of the wiring steps beforehand, so that's what I did, and there's honestly not much to it except for connecting the wires in the same way as pictured in the chart that is either available in the manual, or there's also a printed copy in the package. Next up we'll need some of the jumper caps, and these will be used to adjust the mainboard to the correct settings, the right voltage for the motors, or activate proper communication via the CAN USB. After we made sure to place all the jumper caps, it's time for the motor controllers. There are two different types. The first one is the one with the red heatsink block on top. There will be 4 in total, one for each of the X and Y movement motors. And the second kind is the one with the blue heatsink on top, of which we have 3 in total, one for each of the Z motors. Now it is time to install the Raspberry Pi board on top of the Manta main board, and this is exactly the step I recommended earlier to complete before screwing the Manta board in place, because it is just a lot easier to plug in the board if you can apply some pressure from below the main board. Before installing the bottom plate, I have to put in the skirt part that holds the display, but I later on removed the white printed part of the display in order not to break anything when I turn the printer as long as I'm building it. What I didn't notice in time is that the bottom plate with all the electronics on top needs to be placed with a specific orientation, and the orientation you can see I have is not the correct one. And you will notice this in 2 ways. The first one is that the measurements of the bottom plate seem to be not really precise, and the more obvious one is later on during the wiring process you will notice that some of the cables are just not long enough to fit to the corresponding connectors. Now we'll do the first preparations to build the print bed, and therefore we need 2 of the extrusions, and the longer one needs to have a hole in the middle of it, and that was probably one of the biggest mistakes I did so far, since the length of the extrusion is exactly the same as the ones we used in the frame. And of course I managed to install the wrong axis inside the frame, so I almost had to disassemble the entire printer to swap out the 2 extrusions, and that took me over an hour, probably even longer. So after we connected the 2 extrusions with a blind joint, we'll need 2 M5 T-nuts and 1 M3 T-nut for each side. In order to connect this part to the frame, we will use these printed parts and we'll insert these. I'm honestly not sure what these are called, but they look like bearings but are not meant for spinning, and instead just allow a little more movement in the other directions. Then we put some screws into the plastic, and since the plastic will bend a little bit, they won't allow the fake bearings to slip out anymore. And then we screw these printed parts onto the M5 nuts we placed earlier on the bed frame. But leave these screws a little loose for now, because you may want to adjust everything once we install it onto the rest of the frame. If you like it, you can add the Voron nameplate, but since it was really loose I left it out because I didn't want it to move around while printing. To attach the bed frame to the rest of the printer, it is really helpful to loosen most of the screws, then adjust everything and afterwards retighten the screws. After we are done with all the preparations, it's finally time to get to the real print bed building part, and therefore we have to first remove the protective foil from the metal plate, and that took quite some time because it's really stuck on the plate. Afterwards it's time to properly clean the metal plate, and therefore I used some 99% isopropyl alcohol and wiped everything off with a kitchen towel. Then we need one of the last parts of the CNC metal kit, and that is the print bed locator, which just has to be screwed in from below. Now you can use the print bed locator to align the metal sheet with the rest of the plate. Afterwards we'll remove the foil from the top side and clean that one even more firmly than we did before, because this is the part where you don't want any factory oil or even the grease from your fingers on top. Because if the double-sided tape of the heater won't completely stick to the plate, you might have some problem that it becomes loose, and that's really dangerous since it gets really hot and there's a lot of voltage on it. When you make sure your print bed is clean, just remove the foil from the double-sided tape of the heater and be as precise as possible when sticking out to the heat bed. And you don't want to have any waves or little creases in it, because if the heater can't conduct enough heat to the print bed itself, the heater may break, or even worse, it might even start a fire, and obviously that's to avoid. At last you just have to fixate the ground wire and the thermofuse, and then we can already install the print bed. Now we have two options how to install the print bed, and I decided to choose the more experimental way, and that's with the less heat conductive spacers and the PEEK plastic screws. Now we already arrived at the last major step to make a printer able to print, and that is building the stealth burner tool head. Since it consists mostly of printed parts, we first have to install quite a bunch of the metal heat inserts, and that is done by heating up a soldering iron to about 5 to 10 degrees over the print temperature of the material you're putting the heat inserts in. In our case, since the parts are made of ABS, the printing temperature would be around 250 degrees, so I heated up my soldering iron to around 255 or 260 degrees. And since I want to finish all the heat inserts at once, I skipped through the manual and checked if there are any other parts that need heat inserts, and I did all of them in one session. For example, there were some fans that needed heat inserts. I don't know what material these are made from, but in my case I had to increase the heat of the soldering iron by another 10 degrees. There are special soldering iron tips that are made for heat inserts, but I didn't have any of these, so I used the normal soldering tip and it still worked fine. You just have to watch out, since in some cases the tip is a little too long and you would otherwise damage the plastic, so you have to angle your soldering iron a bit in order to keep everything intact. After we prepared all the parts, it's finally time to assemble everything, and therefore we'll need the BMG kit. That is just a kit that includes all the extruder parts, like some gears and bearings. These bearings have to first be greased, and I tried to put some grease onto a paper towel and then just rub the axis and the bearings on top of it. But later on, when I checked if everything ran smoothly, I thought that this grease might not have been enough, so I directly greased the bearing by spraying some inside the part they will actually run in. We'll make the extruder gear snap in place, and afterwards put in the tensioning screw with the spring and the M3 washing in front. In my case, unfortunately, the little spring was missing in the BMG kit. By now I already contacted Zebra about the broken or missing parts in my kit, and they replied pretty fast, and I got an answer in less than 12 hours later. But at this point I did not receive any of the replacement parts yet. Fortunately, the spring is not too important for now, and we can keep building without it. Next we have to put a bearing and a screw in the part with the hopper-like shape. And to be honest, I have absolutely no clue what this screw is supposed to do, because to me it looks completely useless, but who knows. There probably is some kind of purpose, because otherwise it wouldn't be there. In case you find this little part in your kit, please keep it, because this is the tensioning screw for the filament drive that is used to attach it to the motor. It usually comes pre-installed, but it might just have loosened during shipping. Because you want the gear to run completely smoothly, you might have to clean up the part with a knife or a file. In my case, by default, the gear would not spin at all, and so I had to do quite some work until I managed to make the gear spin properly. Once that is done, we'll close up the inner chamber of the printhead with the part we earlier prepared with a bearing, and then just put some screws in to fixate it. Afterwards, we want to align the filament drive with the hole that the filament is fed from, and therefore you can use some leftover filament or just any filament you have lying around and insert it through the drive and check if the drive gear is at the right position. Afterwards, we'll need 2 more screws to fixate the filament tensioner to the rest of the printhead. And then we'll finally do some electronics again. First, we'll just install the motor, and afterwards we can fixate the board we'll connect all our electronics to, like the filament drive motor, the hot end, or all the fans we installed in our printhead. For this board there's not much preparing to do, we just have to place some jumpers and stick the heatsink on top. Now we'll need another part and place it behind the motor. This one will keep the motor in place and provide some space to add the drag chain holder in the next step. Now we'll attach the part that will connect the tool head with the drag chain that leads all the wires and prevents them from tangling around while the printer is moving. The manual says that the drag chain holder is supposed to turn completely smoothly, but for me that was only possible as long as I kept the screw so loose that the entire part had so much play that when moving the printhead it was just really loud. Before installing the hot end, we have to turn its heatsink by 120 degrees to make the wiring easier. Then we just clamp the hot end between the 2 printed parts and put all the screws in to fixate it. Lastly, for this part we have to cut off about 33mm of the PTFE tube and insert it on top. Now for the front cover of the stealth burner, we first have to remove some of the printer supports in order to get the fans in place and allow some wiring. Usually this would also be the time to add the LEDs, but since I myself don't really like LEDs, I will skip that step. The first fan will just snap in place, but for the second one we first have to remove the mounting ears and file off the remains to get a smooth surface and make it fit in place. Next we connect the upper fan to the second toolhead PCB and screw it in right behind that upper fan. Usually you would also plug in the LED connectors, but like I already said, I do not use them. And now it is finally time to install all the parts we just prepared. I earlier said that the print bed locators were the last part of the CNC kit, since there should be another set of 2 little metal spacers that will now be used to connect the cartographer probe to the printhead. These spacers are necessary because we'll need some clearance above the cartographer where no electronics or metal parts are, because otherwise the cartographer might not work correctly. Connecting all the other parts was actually pretty simple. We just have to fixate everything with some M3 screws. The hardest part for me was routing the wires in a way that they can reach the PCB, because they are cut as short as possible in order not to take up too much space inside the printhead. Watch out when connecting the front cover of the stealth burner that the connectors in the top right corner actually match up and you don't accidentally break or bend some of these. And last we have to put in all of the 4 screws for the front cover and then connect all of the remaining cables to the PCBs. Alright, and with that we are already at the end of part 2 of my Voron Trident build. The last part will be about the initial startup, all the installations we have to do, and then we'll try to print all the remaining parts that we need, for example to build the skirts or the electronics cooling parts. I really hope you enjoyed this video, so thank you very much for watching and goodbye!